Hello, ladies and gentlemen. All right, I'm back to give you the solutions to this using multiple triangles proofs homework. All right, so again, in these proofs, uh, you need to prove one set of triangles congruent first, and use those parts to prove the second set of congruents, or the ultimate, to prove the ultimate proof statement. Okay, in this first one, it actually gave you the two sets of triangles as parts A and B. Okay, so let's see what we have here. So I'm going to just mark the diagram. Given PR and QS bisect each other, okay, PR and QS bisect each other. So that's going to tell me that this is congruent to this, and this is congruent to that. All right. So just I can quickly see that if I take this angle and this angle, I can get the two big triangles congruent to each other. All right, so that's PQV and RSV. All right, so pretty straightforward. Okay, then it says PUV, which is this smaller triangle on top here, congruent to RTV, which is this smaller triangle on the bottom there. Okay, well now that those two big triangles are congruent to each other, okay, I can use the parts from those two big triangles, part A, to prove part B. Okay, I'm going to need to, because right now, really all I've got is, okay, RV and PV. We already have those congruent. Okay, and I have this little angle in here, congruent to this little angle in here. Okay, so those are vertical angles, but I really don't have any other parts, okay, of those two smaller triangles for part B. Okay, but if I look back at the bigger triangles, I can say that angle R is congruent to angle P by CPCTC. So I'm using the parts from the bigger triangle to prove the two smaller triangles. Okay, so that's how this one is going to go. Okay, so I'm going to start with the first given, which is PR and QS bisect each other. Okay, so 1, PQ and PR and QS bisect each other. Okay, and that is given. Okay, from that, I can say PV is congruent to RV, and also QV congruent to SV. Okay. Two, that's by definition of segment. Okay. So next thing I'm going to do is use the vertical angles. I'm going to call this angle, I'm going to call that angle 1, and this angle, angle 2. All right, so 2, 3, angle 1 onto angle 2. Okay. Intersecting lines form congruent vertical angles. Okay. So now those two big triangles are congruent to each other. So triangle PQV is congruent to triangle RSV. And we showed that by S congruent to SAS. Okay. Okay, so now going on to part B. Since this is all part of the same proof, I don't have to rewrite everything. I can just continue. All right, so I've proved part A. I'm going to move on to part B now. All right, so I've already said RV and PV are congruent. Okay. The next thing that I'm going to do is I'm going to call this angle in here. I'm going to call that angle angle 3, and this little angle in here I'm going to call angle 4. Okay, so I'm going to say angle 3 is congruent to angle 4. 5. Again, that's intersecting lines form congruent vertical angles. Okay. And here is where I'm actually using the original set of triangles, the triangles I proved congruent in the first part. I'm going to use their parts to get the parts I need for the smaller ones. Angle P is congruent to angle R. Okay, angle P is congruent to angle R. Okay, and that's by CPCTC. Okay, and now I've got all the parts I need. 7 is triangle PUV congruent to triangle RTV. Okay, and I showed that using, that's ASA now. All right, so that's that one. Okay, so for number 2, all right, I'm being asked to prove ADE and ACE. Those are the two triangles, the two smaller triangles on top, okay, and angle 1 is congruent to angle 2, which are angles within those two triangles, okay? So as soon as I get those two triangles on top, I can say 1 is congruent to 2 by CPCTC. Okay, so let's look at what we're given. Okay, we're given AC is congruent to AD. All right, that's cool. So we've got one side. And we've got BC congruent to BD. All right, now those are not sides of those two little triangles that I need. Okay, but what I can do is I can get the two biggest triangles, ACB and ADB, congruent by side, side, side now. Okay, because I've got AB by reflexive property, I can use side, side, side. Once I've got those two bigger triangles congruent, I can use these two angles up here at the top. Okay, that angle and that angle. Okay, CAE and DAE will be congruent to each other. And then AE is also congruent by reflexive, and I can use side angle side on the two smaller triangles on top. Okay, so I need to prove those two bigger triangles congruent first and use its parts to get the smaller triangle. That's the entire purpose of this particular unit, is being able to use parts from one pair to prove the other pair. Okay, so that's what we're going to do. All right, so I'm going to list the two givens, AC congruent to AD and BC congruent to BD. Okay. That's my givens. Okay. Now those are the two sides. Now two sides of the two bigger triangles. So I can just say by 2, I can say 2, I can say AB congruent to AB, okay, by reflexive. Reflexive. Okay. So now my two triangles are congruent to each other. So 3, I can say triangle ACB congruent to triangle ADB. Okay, 3, and that's by side, 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 congruent to side, side, side. Okay, so now for number 4, I can say that the two angles at the top are congruent to each other. So CAB, I'm going to call them angles 3 and 4. Those two angles up there. Okay, so I can say angle 3 is congruent to angle 4. Okay, CPCTC. Okay, I've already got CA congruent to AD. I've got those two angles. Now I can say AE is congruent to itself. Okay, 5. AE is congruent to AE. 5. Reflexive. Okay, and now I've proven the two triangles at the top. Okay, so triangle ADE is going to triangle ACE. Okay, and we've done that by side angle side. So 6 side angle side, common to side angle side. All right, so that's part A. Okay, so now for part B, it's just one more step. Okay, angle 1, common to angle 2, and that is just 7C, B, C, T, C. Okay, so that's that one.